Good afternoon, everyone. I'm Kathy Kyriakis. I'm the director of the Center for Applied AI, and I'm honored to have you all here today. In the AI community, we often think that the last mile is moving beyond simple chatbots and leveraging systems that maintain context, persistent memory, and operate with high fidelity in large organizations. Personally, I've spent a great deal of my time obsessing about how to implement graph context into enterprise data systems. So it's definitely something I've been passionate about. And I do believe that we're currently at the crossroads where large language models are incredibly capable, but they lack kind of that deep world knowledge to really get at deep reasoning. And so that's why today's guest is incredibly important to bring to the conversation. And I'm honored to introduce Philip Rathle, the CTO of Neo4j. And for those of you that have tracked the technology of graph, you'll know that Neo4j isn't just a player in this space, but they actually created the category. Today, it's a unicorn with over $2 billion in valuation, and it's the backbone for over 80% of the Fortune 100. But Philip's impact goes far beyond market valuation. He's a pioneer in knowledge systems with 30 years of expertise. The author of the GraphRag Manifesto, which has become a foundational text for solving hallucination and generative AI. By combining the relational power of the graph along with the generative power of large language models, Philip's really provided a roadmap for AI that is not only smarter, but more explainable and transparent. He joined Neo4j in 2012 when the category was in its infancy, and has been a driving force in growing the company since its early stages to the global force that it is today. Based in Silicon Valley, Philip continues to shape how the world thinks about data relationships and intelligent applications. So please join me in giving him a warm welcome.
Thanks all. Thanks, Kathy, for the kind intro. Lauren, Kamal, Sanjog, others. It's great to be here. Is the mic working okay? Is this good? Okay, cool. So we decided to title this talk Seeing in 3D because really there's a lot of talk about technology and then impact to society, impact to business. But there's also a shift in mindset and many shifts in mindset that are possible, including at the data layer, which ultimately is a reflection of business and how we think about the world and work with the world. So we're going to talk about how thinking differently about data unlocks groundbreaking differentiation. Differentiation is important, right? You've all tracked the SaaS apocalypse. I'm sure you know how all these SaaS companies that were considered really kind of the darlings of Wall Street just got shattered, and you ended up with inverse valuations where now hardware, you look at the SanDisk and Micron and so on, they're up 10x in the last year, and you look at Salesforce and ServiceNow, and they're way down. So what's the reason for that? So it's useful to think about what your moat is and what competitive differentiation is, more so if you're a software company, but look, every company is a software company in more than one way. And then how to survive AI commoditization, because this is a big problem for companies and for individuals, right? So I've broken down today into a few different parts. So one is, what do we mean by a different way of thinking? Two is a company that everybody here has heard of and touches probably multiple times a day. But looking at them as a case study for what you probably didn't realize is maybe the first trillion-dollar company based on graph and this new way of thinking. We'll talk about how once you're able to think differently, what kind of transformative opportunities are out there for business. Then we'll get into how AI success depends on knowledge, not just data. There's a bit of a conception, which turns out to be a misconception, that I can just throw lots of noise at models and they'll figure everything out. This is actually a continuation of a long trend in data where there's always been this desire on the part of users and promise, I would say false promise on the part of vendors that, look, I don't want to do anything. I want to, don't just give me the answers to my questions, but tell me what questions I should be asking. And there's a limit to that. We'll talk about knowledge and context and what that means for AI. And then there are many parts of the AI stack that are continually evolving. And I'll make a case for why a part of the stack that has a high probability, and I have high conviction that will be enduring, is the AI knowledge layer. And then how do you get started? We'll get into questions. And then I've got a few next steps that are more on the technology side for anyone who wants to dive down that rabbit hole. And I'll look to someone, maybe Kathy, to help me with timing, because I want to make sure I leave enough room for questions. So, yeah.
I think actually that's hard because I have to dip quickly, but
oh, great. Okay.
keep you honest, I promise.
Okay, great. Thanks. Cool. All right, let's dive in. If it will let me. Let's see. There we are. I want to start with a blog post that I read on Substack a couple months ago. Actually, a McKinsey friend and collaborator of mine sent me this from Mike Shu, who's comptroller of the currency. I wonder if we can get this thing hidden so you can see the full slide. Oh, there we go. If you're not familiar with this office, it's a presidential appointee who's responsible for the department that regulates banks and makes sure you don't have, you do pressure testing, you don't have systemic failure in the system like we had in 2008. And he wrote this incredible post that starts with the Sapir-Whorf hypothesis, which I hadn't heard of, but will make sense to everyone here, even if you haven't, which is that the language, particularly if you're multilingual, I grew up in a French and American household and noticed that the way, if I put my brain in French mode, the concepts and the way I think is a bit different from English, not in a massive way, but subtly so. And this hypothesis says that the language a person speaks shapes the way they think and how they perceive the world. Language, in this sense, limits one's ability to understand things, but therein lies an opportunity. If language is limiting, learning new languages can help unlock new ways of seeing and engaging with the world. And then is the even more remarkable statement where he says, this post argues that supervisors, by which he makes banking supervisors, so people who regulate the industry, should learn the language of knowledge graphs, i.e. of nodes and edges. I prefer the term relationships over edges. It's a bit more humane, but to see the world distinct from the rows and columns that have enabled and shaped our understanding of the financial system. And he gives a few parallels, and you've probably seen comparisons like this. Here's the same data, just expressed using two different abstractions. One tabular, which is what we're used to, but then the world tends to show up not in tables, right? Perhaps actually paper forms show up in a form that is naturally lends itself very well to being placed into tables, and actually are the reason relational databases were invented, is to solve the problem of an order form, which is what, database 101, that's the first thing you do, is take an order form and figure out how to properly normalize it into tables. But the world tends to show up more like this. It's complex, it's messy, it's interconnected, and the connections influence the system, and then the system influences the individual things inside. Let's look at the financial system. And even inside of an individual, small portfolio, you have a company which issues stocks, but it might also issue debt in the form of bonds. That stock might be included in an ETF. That ETF might be included in a mutual fund, which might have some options on the same stock. And you can see how things can become very tangled. And if you're trying to understand systemic risk or even portfolio risk inside of a bank, which is one of the ways, or even ultimate beneficial owner, which is a regulatory necessity. If you're a bank, you have to be able to demonstrate to a regulator who actually owns this thing. If I go all the way up the chain, it sounds like a simple question until you consider even like a very, very simple picture like this. And in his post, Mike Shu actually does a little bit of back testing and analysis. And he remembers back in 2008, or this is probably 9 or 10, when regulators were trying to unravel what had happened during the financial crisis. The analysis was well done in tables, and I forget the number, I think it was like 250 tables. And basically no one other than the person who did the analysis could understand what the heck had happened. And then this is a picture from back in my early days at Neo4j. This Friday will be my 14th week at the company and on this journey. So I remember seeing a picture done by someone in the graph community showing the Lehman collapse. And it's funny a decade later to see the former head of the government body that regulates banks saying, if we had actually taken a graph view, we might have been able to actually avert this crisis. He goes a step further. And does anyone recognize this? Has anyone seen the movie The Arrival? Yeah. And The Arrival is this like alien movie. But what I found cool about the movie is very much a story in how language shapes thinking and thinking shapes language. And so this symbol is actually how the aliens communicate. And I won't say more in case anyone wants to go watch it, so as not to spoil it, but it's a very different way of thinking. So he's basically saying, if you look at the world in this different way, look at the world through the lens of graphs, all of a sudden you can uncover new discoveries. So let me shift to a real world example. I got a readout from one of our teams, one of our sales teams a couple weeks ago, and they had just spent a week doing a POC at a large bank where they were doing fraud detection, fraud analysis, and the bank hypothesized, based on our prior experience and what they believed, that their existing systems, which are largely based on doing fraud detection by looking at like standard deviations and standard kinds of statistical analysis, that maybe if we shift and look at things through a graph lens, we might find some things that have been eluding us. Now, sure enough, I think anyone with experience knows that fraudsters are incredibly sophisticated, sometimes more sophisticated than the defenders. And there's a saying that originated with a Microsoft security researcher a while back saying, attackers think in graphs, and if defenders think in lists, then it's like bringing a knife to a gunfight. And within 72 hours of landing, so you have to land a professional services team and bring the data over and then start doing some analysis. But in 72 hours, they'd run some algorithms, which as a byproduct can be visualized to explain to the business what the algorithms are saying. And you can see normal behavior looks kind of like this. It's like little lines and little subclusters. And then, oh my God, what's this thing in this? This is like really unusual. It just pops out. And it turns out just this instance of fraud accounted for more than $10 million in fraud. It was just a fraud ring. It was just sitting out there in plain sight, but it's only in plain sight if you take this view. Another example, looking at a top line opportunity, is there's a media conglomerate called Meredith. They're not a household name, but many of their brands are People Magazine, Travel and Leisure, Better Homes and Gardens, HGTV. And they had this problem with their business, which is also an opportunity. They have 100 million monthly active users on their website who are reading content or across all their properties. But the vast majority of these people aren't logged in. And so there isn't a persistent identity. People don't raise their hands and say, this is me, I'm Philip. And so that limited their ability to make recommendations and to understand what Philip is interested in, which meant they could give recommendations, but those recommendations were limited to finding content that is similar to the content that you're looking at and it's missing out on understanding all my other areas of interest and how it might tie back. So they came to us and said, is there anything you can do in terms of graph analysis to reconcile these identities? And we said, well, actually, there's this one graph algorithm. Actually, there's a class of graph algorithms that do clustering or community detection, which is I'll look at a network and I'll look at the connections and the behavior, and I'll see what things naturally cluster together. And you can do clustering at a more macroscopic level. So to see who are the communities inside of like a social network and who just naturally interacts with whom. And you might have larger community. You might have an entire continent as a large community and then sub-communities inside of that. But you can also dial the knob to get very fine grained with your community detection and say, let's find micro communities around all the different breadcrumbs that technologies leave behind as people browse. Cookies, trackers, IP addresses, MAC addresses. That gets a little scary privacy-wise too. So probably good to know this stuff is happening. And based on that, they were able to tie together a suspected identity. Now, how accurate is that suspected identity or not? Well, not accurate enough that if someone comes in with an IP that has been used before, I'm going to show them bank account information. But if I'm just showing them an article, then that's fine. So they did that, took this massive data set, tens of billions of nodes and relationships, ran some graph algorithms across 163 million unique profiles. And doing their recommendations based on that improved the quality of engagement by over 600%, which is absolutely insane. Like having sat in, board meeting, I had a board meeting this morning at 5:30 a.m. Held in London, but having sat in board meetings on a regular basis and looked at marketing's reports back to the board of what's our progress, we're patting ourselves on the back if we can get like mid-single digit uplift in like a month. 600% is pretty unheard of. So again, an example of a step function on the value side, in addition to the last one on the data protection side. And this is true of large companies and it's true of small companies. Here's another unicorn startup called Jupiter One, who does cybersecurity. So they have unified visibility into your cloud infrastructure. I'm seeing a bunch of companies like this these days. There's a huge opportunity particularly for agents to be able to understand the infrastructure and know how to authenticate, work with each other. And they give you a unified view of assets, context, risks in one place. Context here, they're referring to the infrastructure and the services and the people. And this is where I kind of got the title for the talk I'm doing at Web Summit Vancouver next week for a keynote on the AI stage called Your Graph is in Moat. You're going to see a little bit of a preview today. But they already had a product that was taking what naturally is a graph, had it in a relational database. They took the time to re-platform so that they could scale their platform. Now their platform is entirely graph-based, based on Neo4j. And they found that they went from, this ingest time went from 8 hours to 10 seconds. Query performance went up 100x. Pipeline costs went down by 90%. So you get all these top line technical bits of value, which translate into business value. Because if I can do something 100 times faster, that unlocks new opportunity. That's not just an efficiency. 30% faster is an efficiency. Which brings me to the massive case study, which is actually Google. So let's look at Google, go back to their origin. Back when they first started in the late 90s, you had something like 30 different startups that were tackling the problem of web search. Much like today, you rewind a couple of years and you had all these different companies building vector databases. There's actually a pretty good analogy here. And what they were doing was all conceptually identical and technically identical. They just indexed the World Wide Web, which was it is a technical feat, and it was a technical feat back then, and then let you search for terms. Then comes the challenge of how do I get my best results? because people will gamify that. You ended up with things like a company that's selling, I don't know, selling jewelry. And so they would write jewelry thousands of times on 1 point font, like white over white, that was invisible to humans. It would get picked up by the search engines because these guys were all ranking based on word frequency. And Google came around and said, actually, there's a better way to do it. If I look at their press release from their launch, I've excerpted this, and it says Google's based on a variety of innovative technologies, including sophisticated text matching, check, that's what everyone else does, and its advanced patent pending technology called PageRank, which ensures that the most important results always come up first. So they had exactly one innovation and exactly one small part of their business, which is ranking your results. And that caused them to catapult above everybody else. And what PageRank simply is saying, I'm going to rank each page based on the number of inbound links to that page. And then because you can game that, I'm actually going to iterate a few times, and I'm going to weight the relationships, the inbound relationships, based on the number of inbound relationships from the next node. So it's an iterative graph algorithm. There's a lot of number crunching in there. It's computationally impressive, but it's now become commoditized as the kind of thing that you can pick up a graph technology and use it with your own business. And in Neo4j, I think you can run like 1 billion nodes and relationships in under 30 seconds, do a PageRank calculation, push that back to each individual node as a property, and then just use it for ranking, which we'll get to. That catapulted them above everybody else. That was just one innovation and one algorithm. And that lasted about 12 years. After 12 years, they disrupted themselves with what they call the knowledge graph. And the knowledge graph solved for another problem that they had, which is if I search for, say, Rio, I can be searching for a city, I can be searching for a movie, I can be searching for like a hotel and casino. And so the knowledge graph was their first attempt, actually came out of the acquisition of a company called MetaWeb, which had taken the time to digest the World Wide Web and then classify it and create a graph of what does this stuff all mean? It's a graph of meaning. And whenever you go to Google and you see this pane on the right side, this is actually a knowledge graph entry. And when you see things here like architects, Bernard Maybeck, that's a blue link, which actually links to a node to this person, where there's another knowledge graph entry. Same with Beaux-Arts architecture and so on. And then that lasted about 12 years again until they disrupted themselves again in 2024. And they first unveiled this, and now this is actually integrated with Gemini, but they first launched this at Google I/O 2 years ago with this complex example of, this is much more than a search. It's asking for a travel itinerary based on recommendations of what people like and so on and so forth. So you can imagine having a graph representation of the person, who they're related to, what they've asked about, flight, hotel, and so on, and getting a better answer there. So that's Google's latest evolution with AI also leveraging their knowledge graph. So combining LLMs in the knowledge graph, and graph RAG is just a technical term for call out to a knowledge graph by an LLM to get better results. Let's abstract this a little bit and look at how people learn, which is the same way that organizational data is evolving. So human data progresses somewhere like this. I see a sensory input. I classify that sensory input. I then look at how it's connected to other things that I know. And then once I've done that, I can use it to gain insights by saying, well, this is connected to this, is connected to this. And so here's an interesting discovery. And then knowing how you got there, being able to articulate that, is wisdom. which in an AI age, we would say is explainability, which for high stakes use cases and for regulators is incredibly important. If you look at organizational understanding, you can actually map this to different parts of the data stack. Store and retrieve of data is what relational databases and databases were originally designed for. Is customer logs in, you need to bring back their information, they change their information, you need to save it. That's just store and retrieve. And then came data warehouses, data lakes, data lake houses, and so on. And this is turning data into information, which you might have heard is like a tagline of sorts for BI companies. So let's classify it, categorize it. And then everything else of, okay, how does that information connect? What new insights can I gain from it? And how do I reflect and understand how I came to that insight and explain it to a business person who ultimately is going to be on the hook if the machine makes a bad decision? That's all in this realm of graph database, graph analytics, knowledge graphs, and it's all about connecting the dots. Multi-hop reasoning is a term that's being used to simply connect the dots between things and discover things that are interesting. If you've ever played like the, Kevin Bacon, 7 Degrees of Kevin Bacon, that's exactly it, right? Here's a movie, find the path to other movies that have had co-stars that have had Kevin Bacon. That kind of question is smack in the sweet spot of what you can do technologically and algorithmically with this kind of tech. If I take my decade or so journey working with customers who've adopted this technology and used it, I see something like this, that usually they've reached some kind of plateau based on the inputs and the tools that they have and the perspective that they've taken. And so if we go back to Mike Hsu and his assertion that by thinking differently, you can unlock more opportunity, that opportunity looks like this. Kathy mentioned the GraphRag manifesto. If you're interested, it's I think a fairly accessible technical read that draws a similar analogy. You can see similar kind of S curves to what I drew in the Google journey, where when people first started, usually when people first start building AI applications, they'll just use LLMs or small models, big models, small models, fine tune, and then realize that I can solve certain problems like meeting summarization, that type of thing. But then at some point it becomes not good enough. And then you might do other things like get in vector-based similarity is another step. And that's often not good enough if the stakes are sufficiently high. And what we started seeing a couple of years ago is that companies would raise the bar and actually be able to get to production by integrating a graph approach. And this seems to be the year of context and knowledge for AI. These are a couple pieces written by Gartner in February. It's like every week they're writing a new piece, either about GraphRag, context graphs, knowledge graphs. These terms are all reasonably synonymous. Top trends in data and analytics for 26, handling complex use cases with GraphRag. This one's on context graph, solving AI's institutional memory problem. If you're going to deal with memory, then what better way to store memory than in a system that is modeled after the human brain? You have neurons and synapses. That's very much like nodes and relationships. And then they have all these industry-specific pieces. This one looks at banking and insurance. And again, knowledge graphs are one of the 5. Enable connected data definitions and relationships into a semantic layer. That's another term you'll hear. That grounds AI outputs in verifiable business meaning and traceable lineage while resolving complex logic. And this comes from just April 16th. Like I said, every couple of weeks, they're making new graph prognostications. Data and analytics leaders must design the data and analytics architecture to make the context layer the central brain for AI agents to deliver trusted intelligence. So there's clearly an AI spin here. Let's get into the AI spin. This post went viral in late December over the holidays and into this year. by Jay Gupta and Ashu Garg from Foundation Capital, who predicted that the next trillion-dollar opportunity in AI is context graphs. And if you could say if Google is a trillion-dollar company in itself, then perhaps this is greater than a trillion. And then that's also caused the company I work for to become one of the top three data and database technologies being used inside of the AI space. And so you hear the term context graph and context. That word can mean many things. So in the Foundation Capital post, they defined it in a really interesting way and used the term decision traces, which I'd say is a subset of the way you can understand context, but a really important one. And where this realization comes from is you have many kinds of decisions that happen inside of companies that are undocumented. Now, you do have in like healthcare and manufacturing and so on, banking, you do have cases where you have to follow this exact deterministic path. Let me come back to that because that one is important and interesting and very relevant in the graph world. But for cases where I want to have AI be able to play the role and handle these processes that are undocumented, how do I actually understand the decisions that have been made in the past and from that infer what the right decisioning logic should be so that then you can have an AI agent make decisions that are as good as humans for these particular mundane tasks, but ones that are less predictable. So here, what that looks like, you ultimately want to build something that says, I need a decision around, say, a discount approval. I have an agent that's going to do that. It's going to look at a standard policy. It's going to refer to a system of reasoning. And then it's going to look at things like precedents, exceptions, other considerations, and then come up with some kind of outcome. Another frame that I like to use for understanding what kinds of data belong in a graph, because not all kinds of data belongs in a graph, time series, paper forms we talked about earlier. It's things that show up in a couple of ways. Network is one obvious one. It's data that shows up as networks, includes computer networks, social networks, communications, biology and ecology are graphs, transportation, payment. And I can point at examples of companies, everyone from transportation, Union Pacific, CSX, Transport for London, Belgian Rail, bunch of postal services for transportation. Most pharma companies have a knowledge graph that they use for, among other things, drug discovery, to take the graph of biology and connect it up with the known interactions between all the different parts of the body across all public and private research, and then connecting that to known interactions between the different elements in the body to the different pharma compounds in their database, and then to the different ailments on the other side. Turns out just by doing a connect the dots reasoning operation, you can knock a year off of a 10-year billion-dollar drug discovery cycle. You have the other one is data that shows up as hierarchies, organizational hierarchy, supply chain, bill of materials, asset ownership. By bill of materials, I mean things like car companies have a car which is 1 million parts. Aircraft are about 2 million parts, and it's parts of parts of parts of parts with their different suppliers and supply chains, and those parts group into components and there are interdependencies and so on. If you go to BMW.com, configure your car, there's Neo4j on the back end, just curating the choose your own adventure of what the different part dependencies are and narrowing it down as you go. And then journeys, customer journey, patient journey. This is basically a series of steps through a network. And guess what? The decision traces and context graphs that we just talked about are kind of a combination of all these, maybe more a journey. So why is this important? I want to go back to competitive landscape, which I mentioned at the start, is if you're any company, but especially if you're a software company, you're looking at a spectrum of futures. One is you're going to have your own customer is going to vibe code something which does the same thing as your product in a way that's good enough, and your product is gone. And then the other is some company is going to take whatever it is they do, make it much better, and then be a better competitor against you. So in the software world, this would be someone like Workday or Salesforce who have a significant amount of data already, which they can use as their moat. Just vibe codes a new feature that becomes a new add-on to their platform that their customer can use, which then displaces you again. So risk number one is a business is cannibalized by some model provider, and risk number two is a competitor leapfrogs you using AI. And the opportunity is that AI becomes your competitive edge. So how do you do that, and how do you build a moat that these ugly guys can't just get across? I presented this almost exactly a year ago. There's a conference for any of you who are either startup founders now or looking at founding or joining an early stage startup. SaaSer has been around for more than a decade, and it's kind of like, all about SaaS, but how to do it faster. So it's a place conference that happens in the Valley. Usually, I think it's next week, once a year, where you've got 10,000 plus founders and VCs and people from larger companies just sharing knowledge. And in my talk last year, I presented this, which I think has held up reasonably well, given that everything is changing so fast. And what I postulated is that one's unique advantage can be found if you're a software company in these ways. Number one is valuable and proprietary data. If you can have access to data that no one else does, then you can use it in all the ways that we talked about and more to create differentiation and value. Number two is if you obsess about an experience, particularly an experience that might be something that a company, let's say accounting or closing the books, that's something that every company needs to do, and it's a cost, and it's not something that they're going to invest tons of time in optimizing because they need to focus on whatever their own competitive differentiation is. But if you can own that, create the most amazing user experience for accountants and bookkeepers, then that can be an advantage. Then people might pay rather than build it themselves. That comes along with world-class domain understanding. Of course, a litmus test is you can't build it in an afternoon with AI. And then this is maybe the most powerful one is what are ways that I can get network effects? Meaning, how do I leverage the interaction amongst a community of users so that the more users come in, the more value they're getting from each other, the harder that is to disrupt, because if someone leaves, they might have all the same features, but they don't have that community. And then the other thing that's relevant here is the promise of AI. And you've all probably seen this MIT study from, it's maybe getting a bit old, 6 months ago or so, that 95% of AI pilots are failing. It hasn't gotten that much better. But if I look at clues from inside that survey, a couple of these quotes resonate to me. Is for high stakes work, I need a system that accumulates knowledge and improves over time. So knowledge and then improving over time kind of implies memory. And then model quality fails without context. Here's that word again. And so if those are the things that I need, and I can relate them back, let's get more granular at the causes of AI failure as I've seen them. It's the fact that LLMs hallucinate, and that's unacceptable for mission critical applications. And we actually hold AI to a higher bar than we do humans. Just look at, how many human car crashes do you have, and how many of those make the news relative to, a self-driving car crash. AI is a black box, so it's hard to reason with stakeholders, regulators, customers if you can't explain your decision. LLMs, once they've been trained on something, anything's fair game. There's no judgment about what data is appropriate or legal or ethical to use. And then AI lacks any sense of explicit context. And the root cause, I would say, comes back to what do you feed your agents? And I mentioned earlier that there's a common conception, actually a misconception, is if I just throw lots of data in an LLM, it will figure things out by itself. And someone did a meta study last August, this guy Akash Gupta, and looked at 1,500 papers on prompt engineering and came up with a bunch of myths. And the top myth is that longer detailed prompts equals better results. In other words, there's this term cache poisoning, which is if I throw in more junk, it's garbage in, garbage out. What you actually want to do is you want to curate what you send in, and you'll get better results. And guess what? That reduces the cost massively. It means you can use a smaller model. It means you have fewer tokens in. It means there's less processing to be done. And for those of you who have been watching the news in the last few weeks, token maxing has been, a big topic. And Uber's CIO or CTO just announced that they burned through their entire $3 billion LLM budget because everybody just used too many tokens. So there's real financial impact here at scale. So what we're talking about here is like these yellow things, is this signal hidden amongst the noise. And when I say agents need knowledge, and you can think of knowledge as the signal amongst the noise and how things are connected, you want agents to be able to operate in real time. So if I look at the data requirements and the application requirements from a technology perspective, I need real-time updates and low latency retrievals. So the same kind of thing you get with an operational database. You need to be able to efficiently store structured data, meaning like in relational database, unstructured data, meaning in like PDFs and transcripts, and then semi-structured, bring those together. You need to be able to connect up the silos, because if the scope of my AI knowledge is just what's in a particular silo, say like HR silo or supply chain or manufacturing, then you're not taking advantage of the entire intelligence and knowledge that the enterprise has, and you're not going to be able to differentiate and make as good decisions. You need to be able to store RAG corpus, both vector-based RAG and graph RAG. And then you want to be able to build secure and privacy supporting systems, which means you need data access controls and explainability. And the challenge is, if you look at the systems that are out there today and people's options, well, foundation models are trained on the world's data, but not your data. Small models, sure, I can train them on my own data, but then it's still a black box, hallucinates, and lacks discernment or judgment about what data is appropriate. So that's out. Data structured as static rows and columns is organized to support fixed and simple questions. And then if it's unstructured, it's hard to make sense of. And then you still have the silo problem. And the way people are breaking past this is saying, I actually need a new layer in the stack. I need a knowledge layer. This is a fairly new thing that we've seen for the last couple of years, but is starting to become top of mind for C-levels. I'm actually going to be moderating a group at a McKinsey CTO conference tomorrow downtown, which was one of my reasons for coming here this week, where we're going to talk about this pattern. And so you want it to hold structured context and meaning, uniform memory retrieval layer, to be a uniform memory and retrieval layer for agents, to bridge human and machine understanding. I'll show an example of what I mean by that. To link data across sources. And to do that, you actually want to store your data as a graph. And then that's on top of or alongside your other data platforms. So what does this give you? Let me talk about context in a different and maybe more colloquial, less specific way than as decision traces. You need context in this sense too. If I have Sarah coming in as a customer to the website, and I want to make a recommendation, what do I need? I'm going to want her recent interactions, maybe what was in the shopping cart during those interactions, things she's previously bought, things that she's bought that she's complained about and returned, and then maybe also looking at her household members and things that other people in her household have bought, and then what they've complained about and returned. So that's the kind of like base layer of context that you need to feed your agents in real time for just the narrow subset of your actors in any particular decision. And there's been a whole ton of research, and I'm seeing this out in the field, showing that, for example, with LinkedIn, this is a 2-year-old paper, that they were one of the first companies to deploy and write about GraphRag. Their customer service team was able to reduce their mean per issue resolution time by almost 30% using this simple technique. Here's an example, and how much time do we, oh, okay, I'll keep going and then, yeah, let me skip over this one actually. Connect the silos. So data and systems naturally show up in silos, but if I can connect them up, then I can have agents that can use all the intelligence in the company. And you ideally want to do this in a way that's not boil the ocean, because that's expensive, takes a long time, and often fails because it's so hard. So you want to start small. And a way you might start is to say, I'm going to start with particular use cases inside of certain business functions, and then find areas where, for example, product inventory can actually influence my recommendations and do that based on my supply chain. So you can sort of expand the graph out bit by bit. I talk about transparency. Let's say I'm trying to represent an apple. The way a model will represent an apple internally, or the way a vector will represent an apple looks like this. You can't make heads or tails of it. And the knowledge graph view gives you a shared language. We talked about data protection and discernment, that if I have data in a graph structure, you can apply access controls. And then complex queries end up being easier to express using a graph query language rather than a language like SQL. This is an example from Adobe. This is an example from Uber. And essentially the language that's used to query graph databases and interact with graph databases is now an ISO standard. And you'll hear it referred to as Cypher. You'll hear it referred to as GQL, graph query language. But it sits alongside SQL as one of the 2 ISO standards for database languages. And it just happens that LLMs do a better job of expressing human language complex queries in GQL than in SQL, because that language looks a little bit more like human language. All right, so these are the ones we talked about, which solve for these problems. And if I bubble it way up, an analogy you can think about is your LLM is about statistics, creativity, language. It's spontaneous. It's like kind of the Kahneman fast brain, and then your left brain is the knowledge layer, knowledge, facts, context.